All right. Hello, everybody, and welcome. Hope everybody is doing well tonight. We are picking up where we left off on the last stream, and we're actually going to tackle asset packaging tonight. So we're going to dive headfirst into code on that tonight. Last night we kind of covered the basic ideas behind it, some concepts, started hashing things out. Now we're going to take a look at some of the stuff I was able to accomplish offline, which wasn't very much, but it'll at least kind of propel us in a direction where we can start writing some code. Before we do that, though, first of all, I suppose I should mention really quickly, it is storming here, and the power's already gone out once, so at some point that may be an issue. But regardless, I would like to thank the supporters of the channel. Listed here, we have the partners, who are the highest tier of subscription over on Patreon and YouTube memberships. They are Dustin Punt, Gabby Bashir, and Gerbolis Inc. I'd also like to thank all the other supporters listed here on the screen. They are a combination of the other tiers over on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me cover expenses and grow the channel, things like that, by testing hardware, things like that. So thank you for that. It really helps a lot. With that said, I also appreciate all the viewers here on the YouTube side and the Twitch side. We do simulcast to both. I do watch both chats. So obviously without all of you, this project wouldn't exist. So thank you guys very much for being here. I appreciate you guys. And this is an interactive stream, so if you have a question or a comment or something, feel free to jump in to chat, and we'll talk. Me and Mr. Mustard, how's it going? Good evening to you as well. All right, so where we kind of left off last night was a couple of things. Actually, before I jump into that, I do want to take just a quick second and cover something really fast. So I did do a couple of fixes offline. Most notably, I fixed the window resizing crash that was happening on macOS and cut a new release for that. So now there's a 0.7.1 for that, and that has been also merged into the main branch. So anybody that was having that issue, make sure that you're either using 0.71 or later, or use the main branch. That change has also been merged into 0.80, which is the branch that we're working on now. I also fixed an issue with, and I think I've got it in my to-do list here. I also fixed the UTF-8 wide character handling for Linux. So I fixed that bug as well, because it was relatively quick once I found out what the solution was. So anyway, so where we left off last night was we were basically talking about how our assets were going to be split up between these sort of, so to speak, modules. And we started scaffolding some of our manifest files, and I've gone ahead and just completed that offline. So what we have here is we have any packages or any, I say packages, they're not packages yet, but any of these modules that have assets that go along with them, if we expand it out, there's now an assets folder that sits next to source. And if we expand that out, we'll have, whatever the types of assets are here. In addition to that, it'll also have a asset manifest KSIN. So this is the one we wrote last night. And I did decide a couple of things in terms of the way that we're actually going to handle naming and things like that. So we want to standardize a lot of this stuff so that it's the same across the board, at least for our packages, right? So basically, if we take a look at, let's look at fonts, because this is a decent example. So here are the fonts that are included with the standard UI module. So we have the font files here, and then we have some binary files that go along with it. And or we have texture files. So if we take a look at this Noto Sans 21 pix FNT, FNTs are bitmap fonts. Font configs are system fonts. We should probably rethink those extensions, but for now, I'm going to leave it. But if we open this up, The bitmap font now, instead of having a absolute path, now uses a fully qualified name. So this is basically package, asset type, and then name of the asset, right? And so in the actual manifest, the asset is just known by this bit. So this particular font file references also by something that the asset or the package system can look up. So if we go over here to our asset manifest, and we look up, here we go. So here is the name of that font, right? So it's here, and then we say it's a bitmap font, and then we look here, and it's Noto Sans, and it points to the FNT file, and the FNT file then points to this asset here, and then this is located on disk there, right? And so that's how all of that linking happens, and we're basically going to follow that same pattern for all assets. So any asset that has a reference to another asset, its linking will be done through this manifest, or essentially through the package once that loads this manifest, right? And that's sort of the way that that's going to work. So our shaders, for example, we don't have the fully qualified name as part of the actual file name anymore because that exists as part of the package, right? So we have pick UI here, which is like a pixel perfect pixel shader picking UI objects, and then we just have this standard UI shader, right? And the shader obviously has a shader config, and then frag and vert GLSL files, right? So if we take a look at the shader file, it also uses the fully qualified names, right? So these GLSL files are technically counted as text. The extension there doesn't matter because the asset manifest actually figures that out for us. So we just go by names for things now. So whenever we register or whenever we're going to load an asset, we're going to load that asset by name only. We don't care about path. And that allows us to sort of establish this sort of virtual file system that we have underneath of here, as well as when we switch to binary, the binary blob that we'll kind of pack all this stuff into, all that stuff's completely transparent from the engine, right? So that is more or less what we're working on. Okay, so we kind of got a look at the UI standard one. This is kind of the one that we built last night, but I also went ahead and went into runtime and built this out as well. Runtime just comes with a bunch of shaders, and we have standardized the names of these as well. So we don't have like the built-in dot stuff anymore. That's gone. That's no longer a thing. Of course, we'll have to change code references to that as we go. But we have a color 3D shader. We should probably also make a color 2D shader. That's for something that just renders something as color, like lines, for example. So we have our PBR shader for our static meshes and terrain. We have our pick shader for our static mesh terrain, shadow for shadow mesh or for static mesh and terrain. Then our skybox shader. And our water shader, right? And we'll just kind of keep adding to this list, and we'll follow that same format as that goes on. And then really quickly, here's the asset manifest for that. So this is runtime. This doesn't actually have any references. It's just empty. We could just as soon leave that out if we wanted to. But the runtime has quite a few things that come with it, right? But the biggest one of all is by far the testbed, right? So we're actually going to do away with this testbed assets. I'm leaving it here right now because we can actually still run using this right now. We haven't switched over to the new system yet, but this folder is going to be going away, and it's going to be replaced by the assets are actually part of this module now. So if we expand that out, these are all the things that are included with that. This is going to be our sort of application asset package, right? And if we have a look at this asset manifest file, it has a reference to runtime and plugin standard UI, right? And all this really does is it triggers these packages to load before this one actually loads, right? So we have that, and then here are all of the assets that we have in here that I painstakingly had to enter by hand. We're probably going to write a process that does all of this for us, right? We're only like a third of the way through the file now, right? So I'm just going to page down through this, right? We've got a whole bunch of stuff, right? So that is what we've accomplished offline. So now we're ready to write the code to ingest these files and actually start building out our package system. So there's nothing standing in our way at this point. Let's see. Thanks for the bitmask explanation yesterday. Yeah, no problem. If I take some code snippets from the Kohi source, what credit do I have to give? To be honest, I mean, it's Apache 2.0 licensed, so it's a pretty permissive license. The only thing I ask is that you say that you used it, but I mean, if it's just a snippet or two, I'm not really that worried about it. It is open source, right? It's supposed to be educational, so I'm not super strict with that. Really, where that credit matters is if you wind up releasing something with it, then you could say something along the lines of, portions of the code that are based off the Kohi engine, and that would be sufficient, right? But yeah, if it's not something you're planning on releasing, I wouldn't even worry about it. How should I deal with external libraries that I need to use in many files? Do I include once in the main file and once in each file that needs it to be inside? Yes, typically. Yep. Let's see. Seems like a lot of work, to be honest. Yep. I mean, kind of, yes, but I don't know. I don't suspect it's going to be that bad. At least not the first version of it, right? Because it's literally just going to be forwarding to a file on disk. And we're going to use our asset loaders that we already have. I did also add to the to-do file a little bit, just to kind of brainstorm and think about all the steps that we need to take in order to get this thing going, right? So I've kind of created this section here. So we've done the reorganization of assets. We've renamed all the assets to be, package asset type name, right? So we follow that. Let's see. Set up one manifest file, including a list of all these. Exclude source file. Okay, actually, this one's already done too. Okay, so there's a few things that we're going to have to rework. One of those things is our import of static meshes, right? The OBJ files, because OBJ files, you have that, and then you have a MTL material file that has a whole bunch of material definitions in it that we then parse and break out into our custom format, right? And so we're going to need to rework that process a little bit, as well as the OBJ import process. Now is the time where we're going to actually start pulling some of that stuff maybe out of the engine, or at least start preparing to pull it out of the engine, because this import process really should be something that the runtime doesn't have to be concerned with, right? It should be something that the application itself should drive, right? Because if you think about it, really that's more of something that you would do in an editor, or maybe a debug version of your game, but the engine itself, the core runtime, shouldn't really be responsible for that. So we do need to think about that a little bit. We'll tackle that after we get some of the other basic types out of the way. We will need to regenerate all of our Kohi static mesh files, because those contain string references in the binary to pathed material definitions, right? That no longer line up with what we have, I think. So I think we're going to need to regenerate these all. So this kind of depends on these two guys. This one's kind of minor, but I've got thinking, like, I want to rename all references to mesh, or from mesh to static mesh, right? Because we really mean static mesh when we say mesh, because a skeletal mesh or an animated mesh is going to be something different. It's going to require different data. It's going to be loaded differently, all of that stuff. So we probably really ought to rename that at some point. Create the K package interface in Kohi core. This is going to be in the core because we need our external libraries to be able to access it as well. And that also makes sense when you think about it, because our platform layer is also in the core, right? So like our platform, our file system, all that stuff is here, right? So it makes sense that the platform layer and ultimately our virtual file system exists at this level too. Point kpackage files to files, or point kpackage to files on disk for debug builds. So this is the first version of this that we're going to be doing, right? We also want to tackle asset hot reloading as part of this. And I haven't just decided whether I want to support that in the package or third party yet, right? Or not third party, but externally, right? So this kind of, I haven't really decided how I want to handle that just yet. But I'm thinking having asset hot reloading might be a nice thing to have. We also have, we need to generate manifest files or have a utility that does that for us. So that's something we want to do as well. That can wait a little bit. We need to create the binary blob format. So this will be the actual kpackage file that we read and write from. So that's ultimately what we would bake for a release build. So that can come way later. And then we need the ability to point a kpackage to a .kpackage file for release builds versus on disk, right? And we need a switch to be able to do that. So those are basically our tasks that we have to go through. All right. Let's see. Why are you using OOP in the UI? I mean, I'm using some concepts of OOP. I wouldn't call it OOP like explicitly, but there are some concepts of it in there. Just because it seemed simpler at the time, right? It's a way of doing it. Remember, we're going to be writing more than one UI system too. Taman, how's it going? Trash Can, good to see you. Dr. Elliott, good to see you as well. Welcome. Hope you're all doing well. Omnifidus with a watch streak. Appreciate that. Just found a bug in Twitch. Whatever, keep up the good work. Awesome. Yeah, there's lots of bugs in Twitch. All right. So, what we're going to start working on is sort of the basis for all of this stuff, which is we're going to start thinking about the interface for the kpackage system. So this guy is actually what we're going to work on now. These aren't in any particular order anyway, but this is what we're actually going to start working on now. So we're going to start scaffolding that. So I think, do we want to put that under platform? I think that kind of makes sense because it's a platformy thing. So we're going to create a kpackage H. Obviously we'll include defines H. I'm not sure what else we'll need to include besides that, but we'll definitely want our types. Okay, so the things that we're going to need to do for our packages is we're going to need a representation, first off, of an asset manifest, right? So a code version of one of these guys, right? So actually, if we split and open up, let's use, I guess we can do this one. Right, so we basically need to mirror sort of how this is set up. So let's type def this. Right, and in here, this is going to have I think we're just going to call this name, right? Simple enough. I'm not thinking we're going to use like a handle or anything like that just yet. I think we'll just go with that. I suppose we could also store off the path to the actual path to package file, right? Null if loading from disk, right? So depending on how we load it, this will either be populated or not. So we've got that, and then we'll need, let's do assets first, right? So we'll need some sort of definition for assets. So we'll type def, another struct, whoops, if I could spell it right. And let's call this asset manifest asset. That's kind of redundant, but I don't want to say manifest asset either, because then you have asset manifest and manifest asset. This clearly makes it a subset of the asset manifest. We can always rename it, but I'm not going to waste time on naming right now. All right, so each asset can have a name. It can have a asset type. I think I'm going to save that as a string for now. And a path, right? And so if loaded from binary, this might be null. I'm going to put the to-do on that because I'm not 100% sure. I don't know when we actually bake that package, I don't think we need to store off this information. We'll see. The other thing that, well, I know we were kind of talking about like having a reference, but I don't know if I'm gonna worry about that just yet. Because we have references here, we can look that up in the other package. So I don't think I'm gonna worry about that outside of these guys. I don't think I'm gonna worry about having references at this level. There is also another potential thing that we could run into, where, let's see, materials are probably not the best example of this. Like a static mesh, right? So one of the things that can happen with a static mesh is usually like, this is our custom binary format, right? So this is what gets included in the final asset manifest. I was thinking that maybe we also support like a source path, right? And this would be, you know, assets, models, Vulkan.obj, right? And maybe this is what is hot reloadable. But I don't know if I want to do that yet. So I'm not going to support that just yet. I'm going to brainstorm on that and think about it a little longer. We're not building hot reloading tonight anyway. So we'll take this one step at a time, right? We'll get the basics of it out of the way first. All right. So we have, basically our assets are going to look like this when they come from the manifest, right? So we're going to have then, for simplicity's sake, we're going to have U32 asset count. And then we're going to have a asset manifest asset array assets, right? And so that's going to represent this array of those things, right? So we'll just sort of serialize into that. And then also we need to think about these reference packages, right? So a package reference, all it really needs to contain is the name of the package and where that package is located, the folder, right? I think we're always going to say asset manifest.ksn needs to be what the asset manifest is called. I think that's going to be a hard requirement, and I'm fine with that. We don't really want to allow that to be like named just anything willy-nilly because then it might not be clear as to what it actually is. So here we're actually going to have a structure that looks almost exactly like this. So let's just copy pasta this. And we're going to change this to reference. Right? So this is going to be a reference to another package in an asset manifest. Wow, the auto indent is doing some weird stuff here. Okay. Just so we have clarity on what that is, we don't have type here. So all we need is name and path, right? And then here we'll also have U32, reference count, and asset manifest reference references, right? And that's more or less what our asset manifest is going to look like. So the way that I'm thinking about this is there's two ways that we can load a K package, right? One would be from one of these asset manifests, and the other would be from one of the binary files. So we're really going to have two entry points into this. So first off, actually, let's type def struct, and we're going to call this K package. Right, so this will be the actual thing. And let's give it a name for right now, so that we've got something to work with. Obviously, we're going to be expanding that. So we want this to be accessible to. Well, actually, do we need the package to be accessible outside the core? Or do we simply say that the package is like something that doesn't get exported outside the engine, right? Like the actual package interface. Because realistically, the package interface is going to exist. It's going to exist underneath the file system. I'm going to export it for now. That may change. So let's do a B8, and then we're going to do K package. Create from manifest, right? And then we're going to take a const pointer, or a const pointer to manifest, right? And then we're also going to do K package pointer out package, right? We'll follow the sort of same pattern that we do a lot of the time, right? We're going to have adds here in just a second, by the way. So I guess before we get into ads, I guess I should mention that we do pause the stream for ads. Twitch gives us ads once every 30 minutes for up to 90 seconds, depending on region or locale. So I like to pause the stream whenever those come up so that nobody misses anything. And I do see that there is some questions on both sides, so I will answer those when we come back from ads. But yes. So let's see. Doing the asset packaging thingy, and then we're going to start making the very first game made in Kohi. Yes, that's correct. What about a reference struct? Do you mean this guy? I don't know how long ago you sent that. Singy, hello. How's it going? Good to see you. All right. Tammin, you're at 81% for the goal of credit redeem on stream. That's awesome. I haven't 100% decided how I'm going to handle that, but I have some ideas. So when you redeem that, we'll discuss it on stream. We have ads. Pete's Astrophotography. Pete's Astrophotography. I can't talk tonight. Hello, how's it going? Oh, before you created the struct, obviously. Okay, gotcha. I updated the ad screen, by the way. Got to get that water in there. I might have to update like these, the Kohi icon at the bottom to be a white version of that instead in the name of the stream. Just because it looks a little bit weird now. But I like having something up there besides just the plain background. You actually got an ad on YouTube? Yeah, I did trigger them over there, so I wasn't sure if that actually worked, but okay, cool. For some Austrian bank, that's hilarious. I love how the ads are just like seemingly random for a lot of people. I know some of our Brazilian folks got ads in French, I think it was, at one point, which is just completely wrong. All right, almost done with ads. Okay. Oh, you're in Austria. Okay, that makes more sense. That makes a lot more sense. Okay. Schwarzenegger is Austrian? Yes, I think he is, actually. Okay. So, Tammin had a question. Actually, more of a statement, I suppose. The game will need to access the package, so its own assets will be stored on the K package, right? Maybe the creation doesn't need to be exposed, but access, I think so. So what I'm thinking is I kind of want to have like a file system, get file or something like that, or get asset, and then you provide an asset type along with it. And then that reaches out to the appropriate package and does the thing, right? I want to keep this interface specific to a specific package, right? And so I'm thinking the file system will sit on top of and use this and know about multiple packages. And then it would also handle the parsing of the asset name, right? The fully qualified asset name. And then know whether or not it has that package loaded, etc. And so I'm thinking like direct package access, even for reading, is probably not going to be a thing. The only thing that I could see having that direct access would be the editor, which is why I'm thinking I'm going to export it anyway. Safe Adam, by the way, thank you for the follow. Appreciate it. The VFS will act as a librarian, more or less. Yep. That's what I'm thinking, at least for now. That may change. Okay. So in the ad, they were baking pizza. What does that have to do with a bank? That's a good point. Yeah. I say that about a lot of commercials, though. All right. So let's do kpackage. Create from file. Do we want to do file? Yeah, file. So this is going to be like one of the... Actually, do we want to do file? Or do we want to just hand it the binary stream? Let's do from file for now. We can always change it later. I suppose the file system could be responsible for doing that too. do we have... I just thought of something, actually. Yeah, we don't have the loaders at this point. So something would need to load the binary and hand it to this. Okay, I'm fine with that. So let's do, instead of from that, let's do from binary, right? And we're going to do just a void pointer, right? And we're just going to say bytes, right? And then we're also going to say U32. Actually, let's go U64. Size, right? So we'll do size, we'll do bytes, and then we'll do K package, out package. Okay, so what I'm thinking in this case is the name in the case of the manifest is going to be read straight out of the file. So that's fine. I'm thinking the binary will wind up doing the same thing too. It'll have like a structure that'll have basically all this information in it, just serialized in binary format. So it's a quick memory drop, right? So we don't really have to parse and stuff like that. So I guess, yeah, we could do it this way. That should be enough information to create one, right? And then it returns true on success, false on failure. Obviously, we're going to have the requirement of K package destroy, and this is going to take a K package pointer, right? We need the ability to destroy them as well. Free up memory. And then besides life cycle stuff, the only thing that we're ever going to have to do from it is essentially, for now, we're going to just load stuff, right? As far as baking a package, I think we're going to handle that a little bit differently. We might externalize that from this library. So let's do let me think. Let's do a B8. K package. There's going to be two ways of obtaining data out of this. Data in this file is either going to be stored in text format or in binary format. Or maybe I'll just store it all in binary format. But essentially what this is going to do is it's going to return like this, for example, either in text or binary. I haven't decided yet. I might go binary on everything, but for now I'm going to split it out. So we could say you know what, maybe binary would be easier actually, if we just treat everything as binary. Let's do K package asset bytes. No, asset bytes get, right? So it's going to take const K package. Wait, no, we don't even want to do that, actually. Or do we? We do. Because we're going to have the virtual file system layer determine what package, right? So it'll determine that at that level. It'll parse that out of that string. The only thing that we'll have to ask here is the type and the name. And I suppose instead of a B8, we could just do a void pointer here. right? And if it doesn't find anything, it just returns null. Right, so it's literally just a bytes in, bytes out. And then it's up to the resource loader to do something with those bytes. So the resource loaders are no longer going to be reaching out to the file system, worrying about extensions, any of that crap, right? It's just going to get it all from this guy. Do we need anything else? I don't think so. If we do everything as binary, then all we're working with is just straight up bytes. We will need, yeah, there is one more thing actually. We'll need size. Need to know how large that block of memory is. I think that's it though. From Lake, how's it going? Be watching quietly from a distance, that's cool. Let's see. It would take much longer if you hadn't created Kaysen back in February. True. True. It's actually saved me a lot of time, and I want to convert a lot of other stuff that doesn't use this to use this, because it's been quite the lifesaver, actually. All right. Is that really all we need? Simple enough. I guess it is. Okay. All right, so let's go ahead and create the C file. So let's go add a new file. We're going to go kpackage.c. Include kpackage. And let's start filling this stuff out. So okay, so we'll just start stubbing this stuff out. All right. Okay. So if in this case there's no manifest, or there's no out package, logger, k package create from manifest requires valid pointers to manifest and out package. So we'll return false on that, right? Otherwise, we can start doing the thing, right? So now we need to start thinking about like how our data is going to look internally. For this guy, the package itself. So what I'm literally thinking here for the first brute force attempt is we literally save a copy of the manifest and just access it directly, because it already contains what we need as far as path and name for lookups and material type or type of asset, right? So I'm thinking we could probably just literally use the manifest instead of creating a copy of it and having an internal lookup table that is that. I'm thinking we can do that. Otherwise, we've got a bunch of copy operations. Now, the drawback to doing that is when we go to read from binary, we're not going to have offsets and sizes. Maybe we shouldn't do that. Maybe we should have internal structures. Let me not be lazy. What I am going to do, though, is I am going to copy let's see. I guess, yeah, I'm going to copy this guy. Do I want to have... Let's kind of try to keep this. Let's try to keep this somewhat opaque. Let's do struct kpackage internal. Struct kpackage internal data, right? And then this can be defined in here. Right, where we can create our sort of arrays for stuff. So in here, we're going to call this an asset entry. Right, and we're going to have a name, a type, which I might not actually... I'm not going to keep that. We'll keep path. Actually, let me get back that. If loaded from binary, this might be null. If loaded from binary, this will be null. And then we'll also have U64 offset U64 size, right? If loaded from binary, these define where the asset is in the blob. All right, so we'll either use path or we'll use the offset and size. Which I suppose I could be like fancy and do a union in here and just use maybe 32-bit offsets instead, but yeah, who cares? Who cares about fanciness at this point? Okay, so the internal package is basically just going to be our... It's not going to be quite a flat list of asset entries, now that I think about it. Because probably what we should do is when we look something up, right, we also provide a type. Because theoretically, we could have two assets name the same thing, which is valid if they're different types, right? And so what I'm actually thinking is we have lists of these asset entries per type. And then when we do this, we say, okay, what type are we looking at? And then search that list. That'll keep us from having to search one massive list for everything. So let's do type def struct asset type lookup, I guess. Set type lookup. And then in here, U32 entry counts, and then asset entry array entries, right? And then the package itself has U32 type count and asset type lookup types. And so we're basically just we're gonna translate this list into sets of lists of these guys. I think that makes sense. There's a missing quote on the 16 default name case and file. Ooh, that would have been gross. I like to think that my parser would have caught that and bleated about it. I think it would have. But thank you for pointing that out, because it's one less thing I'll have to verify. I really need to write a language server for this so I can actually like highlight it. I have no idea how to do that though, so maybe we'll try that on stream at some point. All right. So I guess what we'll do. Should I make D-arrays for these? That might be easier initially to set things up. Because what I'm also thinking is, if we take a look at something like UI standard, right? It only has fonts, shaders, and textures. It doesn't have everything. So we don't really need to bother with creating empty lists for types we don't have, right? So I don't want to have like some pre-existing like list of asset types that I constantly have to modify whenever we add a new asset type, right? So what I'm thinking is we only create the asset types that we need. So if we're going to do that, maybe we don't need this type count. Maybe we just use a D-array for that. And incidentally, we probably could do the same thing for this. Thinking about it now. Just use D-array for that. Be a lot easier. So let's go ahead and include that. Containers. All right, so create from manifest. So the first thing that we're going to do with this is if, well, just manifest actually. Manifest name exists. We're going to do, need something else here. Include strings k-string. We're going to do out package name equals string duplicate manifest name, right? And then if we don't have that, we're going to bleat about it. Actually, we're not going to do that because we're not going to allow a manifest to be parsed without a name. So this is going to be a hard error. This is actually going to stop us. Manifest must contain a name. Right? References. References, I think, can be handled by the file system. I'm not going to make this worry about that. Yeah, that should be fine. Okay. Also, before we go any further, I also want to include another thing. Memory, whoops. K-memory. We want to zero the memory of out package. Size of K package. Right? That way we don't don't have any weirdness in there. The next thing is the internal data. So I think that's the only other thing in there. Yep, so internal data equals kallocate size of k package internal, and then Mr. Mashiro, thank you for the follow. How do I want to tag this? I don't really have a tag that's appropriate for this. I guess I could use resource, right? And we'll just have to make sure that when we go down to destroy, that we handle that as well. So, in fact, actually, let's kind of match our creation here with destroying. So, if package name string free package name, and then if package internal data k free package internal data size of k package internal, and we'll free that under resource, and then we'll do a 0 memory on out package size of k package internal, or it should just be package rather, not out package. All right, so that's cleaned up. Space this out a little bit. And if we call this, we're actually going to say k package from binary. Makubaku, thank you for the follow. Create from binary, not yet supported. We'll write this later. Return false, false. To do the thing. Okay. So the next thing that we're going to do is we're actually going to process the asset manifest itself. Which I suppose now that I'm thinking about this, what is actually going to parse this file? Do we leave that up to the file system? I think so. I think I'm okay with that for now. It'll give us a separate thing to tackle, right? Okay, so process manifest. All right, so manifest U32 asset count equals manifest asset count. For U32, I equals 0, I is less than asset count plus plus I. And then we're basically just going to loop through each one of these. I'm thinking we should probably write like a small function to check to see if a material type or an asset type exists, and then push to that list if it does, or create it and then push to it if it doesn't. Does that need to be a function? Probably does, because we're going to need to call it from here too. We also need to call ads. You know, because we got to pay the Bezos. Bezos has got to make his scratch. Cool background. Thanks. I appreciate that. Yeah, that's a little bit updated because I figured, you know, hey, we have a decent looking area that we can take a screenshot of. Why not use it? Love the new background. Thanks. Appreciate that. I think as we continue and we add more stuff, more cool looking stuff to the engine, we'll probably update that every once in a while with that. The Discourager of Hesitancy rated. Thank you so much for the raid. I appreciate that. What'd you get up to on stream tonight? We're in the middle of an ad break, actually, but... What'd you get up to on stream tonight? And as soon as we're done with the ad break, which will be here just a second, we'll jump into things. Jump into a quick intro. All right, cool. So ads are dead. So good timing, by the way. So welcome, Raiders. Working on a small game with no game engine. I love it. It's right up my alley. I think I saw you earlier today. NSDev. I know this man accidentally came across his YouTube today. What a coincidence. Go figure, right? Big respect. I appreciate that. Thank you. So let me give the quick and dirty sort of intro here. I could have swore I already had this open in a window somewhere, but maybe not. There it is. Okay. So we are writing a game engine from scratch in C using Vulkan as our initial rendering backend. And this is designed to be sort of an educational series. So it started off as a tutorial series on YouTube. We changed formats, tried a couple of different things, ultimately landed on the live stream format that we see here. And this has been going on for about 3 years at this point. And the reason that is because I only work on this part-time, right? If I was working on this full-time, we're talking 6-8 months worth of work, probably somewhere around there. But yeah, we are creating almost everything from scratch. And we have a nice little thing up and running. I'll show you here in just a second. Vulkan is our initial rendering backend, and I say initial rendering backend because we actually have plans to support both Direct 3D and Metal, potentially OpenGL. Haven't really decided on that yet. But it is cross-platform, so it's available on Windows, Linux, and Mac OS, and it is free and open source, which means it's available on GitHub. I'll drop a link here in the chat so that you guys have that. And then it is also Apache 2.0 license, which basically means if you use this, all I ask is that you say that you used it. And so it is 100% open source, 100% free. There will never be any royalties or licensing fees of any kind. It will always be free. It is also approved for commercial use. If you wanted to use it for a commercial project, have at it, right? It looks like my bot isn't actually dropping the links tonight. So I'm going to put a link to the website manually because it looks like it's failing across the board. So I'll have to fix that at some point. But coheengine.com is basically the center portal for the project, where we've got the links to YouTube, Twitch. We've got a Discord server with 900, approaching 1,000 people on it. We've got the GitHub here, Patreon, all that good stuff. And then there's also a stream here that says I'm offline for some reason, even though I'm not. So that's cool. There we go. Okay. I guess just because I had this page open for so long. But yeah, I can wave to myself in perpetuity. And so, yeah, it's that's basically what we're working on. What we're doing right now is we're actually building a asset packaging system. And so we need a way to be able to package up our assets and be able to also access them from the engine in a file system agnostic way. And so we're essentially building packages like you might see in like Unreal or something like that, where assets are sort of rolled up. But then we also have direct links to past assets on disk for development purposes that we can hot reload and things like that. And that's kind of what we're working on right now. I think because I haven't actually built this yet, I think I can actually run this real quick still. Because I haven't actually tried to build it, so I can show you guys kind of where we're at. So we've got some basic meshes loading, some very basic PBR style lighting with cascading shadow maps. We just put this water plane in last night, actually. And so it also responds to the PBR lighting and shadow maps. And then what you might have seen on the ad screen was this sort of as the background right here. And so we just recently added this, right? And in addition to this view, we've got a couple debug views in here. So we've got a lighting only view where you can kind of use this to debug what's going on with lighting or normals. We can take a look at that. We can also take a look at the cascading shadow maps, so the different cascades, where red is sort of the closest one. And then that's followed by green, and then blue, and then yellow, and then it should actually fade out to white eventually. Doesn't look like it's happening for the train for some reason. I'll have to figure that out. But we have that. Then we have the standard view, and then we also have the ability to select different objects. Maybe I'll use the car because it's a little bit smaller. And we also built a gizmo that we can use to manipulate it, right? So we can rotate it, the standard, move it around, scale it, whatever, So I can scale like that, right? Or non-uniformly scale, even invert it, right? And it handles that. And so we can also write out to the scene file, so we can actually make changes in this, hit Control S and it'll save. I don't want to do that because I messed up the car model. But yeah, that's kind of where we're at right now. And now we're actually in the process of packaging up assets. So, all right, so let me catch up on chat really fast. Really like your C style of coding. I appreciate that. +1 for that. Yeah, I try to keep things, somewhat neat. And I used to actually do a lot of C++, but my C++ looked remarkably like C, and so I just kind of switched to C and I never looked back. I write in C++, but I don't like it too complicated. I agree. I like C. It's simple. At the same time, it's fast and powerful. I agree. Notice that compiling C code with Clang includes most of the optimizations that C++ has, but GCC and MSVC don't do this as far as I remember. That's somewhat true, yes. Yeah, I also love the compilation speed of C versus C++. It's a huge difference. This looks like a really cool project. I've got the link open for more study later. One thing that makes me sad is the NeoVim tag in your channel. Oh, why the hate for NeoVim? I love NeoVim. I'm using a horrible Frankenstein of C and C++ and OpenGL. I mean, when you say horrible Frankenstein, though, is it like C style C++? Because I programmed like that for years. Not to hate, but you love Emacs. That's fair enough. It's whatever you choose. I still am stuck using this guy for debugging. It's the editor that shall not be named, but it is still a decent debugger. So around here we just say VS like that, just because it's a family-friendly stream, we can't be saying things like VS like that. So, but yeah, other than that, we keep it pretty open around here. Let's see. Recently learned about compiling C with Zig. Did you try that already or heard of it? I do want to try that, actually. I know of it. I just haven't tried it yet. Keep it clean. Exactly. Yep. Editored Voldemort. It's funny. All right. So, basically, the idea for our packaging system for assets is we've got this sort of asset manifest over here is kind of what the file looks like. This isn't a custom language that we wrote. It looks a lot like JSON, but it isn't JSON. It's a language we call KSON. So we in one of the things that we explore, since this is an educational series, we wrote our own storage format. And so that's what we're looking at here. But basically the gist of it is we have different packages, right? So testbed is sort of our driving application. So that's what actually is running the runtime. And it comes with all of its own assets. And then we also have the runtime, which comes with its own assets, right? So it comes with a bunch of shaders, basically, by default. And it has its own asset manifest, right? And so that's basically just a list of assets that are referenced by name, type, and then a physical path on disk. And so our packaging system is going to have two facets. One of those is it's going to be essentially just a pointer to a file on disk for debug builds. So that way we can do asset hot reloading, things like that. And the other aspect of it is we are going to have a binary blob that all this stuff gets written into and packaged and sort of baked into a package that gets shipped with the release build, right? So we're kind of building out the debug version of this now, and then I think the binary version, the baked version, will actually be a lot easier to deal with, believe it or not. But yeah, that's kind of the concept. So we have these different packages that have different sets of assets in them, and we can reference those things by name. So we can say something like, I want testbed material 16 default, for example. And that'll allow us to very easily just reference that by name anywhere in the engine, and the engine doesn't have to worry about whether it's pulling it from disk, where to pull it from, or any of that stuff. It's completely all abstracted away, and it's up to the packaging system and the file system to handle that. Thank you for the follows, by the way. I also forgot to give you a shout out for the raid. So there you go. I think I tossed you a follow earlier today because I think I was lurking in your stream earlier, I want to say. Yes, I did. I am following you. Okay, awesome. So welcome. Okay. I think you guys should be relatively caught up. I know that's kind of a large information dump, but here we are. Okay, so we were working our way through processing this asset manifest into internal lookup tables. So we essentially, our package has this internal state, which for right now just has this single lookup. So it's a dynamic array of types. So we're going to store the assets by types. And so I suppose I could put the type. Right, the name of the type there. That's technically going to be looked up in a hash table, so that won't matter, but for debugging purposes, it might help. So we're going to have asset type lookup, which will have each type, like material or texture, static mesh, scene, all those different kind of things. Will have their own one of these, and then each one of those will have its own list, right? And we're just going to create these as they exist in here, so that we're not creating for types that don't exist. So basically, we're going to load in this asset manifest, which becomes this structure here, which is basically the code version of this. And now we're processing that. And then when we go to request an asset out of here, we say, for this particular package, for this particular type, I want the asset named this. And that'll either give us 0 here for an out size or the size of that in bytes. And then it'll return either 0 here if it's not found, or an array of bytes of this size that actually contains the data. And then our resource loaders can actually take that binary data and do what they need to do with it. Okie dokie. So we are literally at the beginning of setting this up. So we're going to loop through the asset count, which here is just this whole list of things, right? Goes all the way to the bottom of this file. So for each one of these, I think we're going to say when we parse this file, or when we deserialize the file, we're going to check and make sure that none of these things are blank, right? And we're going to throw a hard error to say, hey, your assets are invalid, you dingus, fix it. And we might also do like a duplication check during parsing as well, instead of relying on this to do it. So we'll set that up at some point as well. Okay, so I guess we'll do a search for a list of the given type. And for now, we're just going to brute force this, right? And we'll come up with something that's a little bit more robust later. But since we're building this is only going to happen on startup. So I'm not really that worried about it. U32, j equals 0. J is less than. Out package, internal data. Oh, you know what? I need to actually get... I need to get the counts of this. U32 type count equals the array length. Oops. Paste it there. And then we can do type count here, right? And we have to do this every time. Whoops, forgot the J++. Oh my God, keep hitting the wrong keys. All right, so we're gonna have to do this every time because there's the possibility that we add a new type on the iteration. So all this is just a quick memory offset internally and a quick lookup. So it's not like there's a lot of overhead with this. There is one thing that we didn't do though. Out package, internal data, types equals darray creates, and the type of that is going to be asset type lookup. So we need to create that dynamic array first. Thank you for the follow, I appreciate that. Super cool project, and I like your style. Got to run for now. No worries. Appreciate the raid. Thank you. Keep my eyes open for when you are streaming. This is right up my alley. I've got so much to learn about game dev and streaming. Didn't know about the shoutouts until just now. That's fair. I didn't know about them for like the first 3 or 4 months I was doing this either. So no worries. Zazoza? I think it's Zazoza. I hope I pronounced that right. I haven't commented much on this chat, but know that I really admire your work. I appreciate that. I myself tried to create my own game engine, but I often lack the courage to finish it. That's fair. You got to be really stubborn to push through it, right? There have been times, and some of you know this, those of you that have been around for a while, there have been times where I'm just like, oh, man, I really want to do something else, right? But then I push through that and I'm fine. So you just have to learn how to push through it, you know? You have to be more stubborn than the voice inside your head that's telling you that you want to quit and move on to something else shiny, basically. Enjoy your vibes. Thank you. I appreciate that. Really appreciate that. Thank you. The beep sound is a sensor by YouTube. No, that's a button I have on my Steam Deck, so I can just hit it at any time like that. Yeah, to censor myself. Like when we're talking about VS. That's a button that I hit to do that. Are you planning on using UUIDs to reference files? Many game studios prefer them because they allow the files to be renamed and moved without issues, like a Unity type deal. We could do that. For this first version, probably not, but I don't see any reason why not. That's dingus-oriented programming. Yep, agreed. Dingus-oriented programming for getting the J++ there. Yep. There's many ways to generate UUIDs with many specs for different purposes. There are libs, both Windows and Linux, to do it. Yes. Not the actual UUIDs. How do the UUIDs correspond to the files? Oh, I see. You're asking. Okay, never mind. All right. So we do have a way to generate a unique 64-bit integer, which I might use for those lookups, right? Because integer lookups are super fast. You can have meta files like Unity. That way developers can move the files together. Yeah, I mean, that's certainly something we could expand on, right? Our first iteration of this is not going to be that advanced. But there's no reason we couldn't add that. That's a good idea, actually. You can also have it in the registry or in a converted file. Yep, that's true. So, I mean, if you think about it, like this asset manifest is sort of our metadata, right? It doesn't really contain much right now, other than here's the name we're going to call it for lookups, here's the type of thing that it is, and here's the path on disk. And if we're reading it from binary, it'll also have a offset and a size into that binary blob, as opposed to a path, right? But yeah, we could certainly add more data to that to make that work a little bit better. All right, so for this, I think what we're going to do is we're going to do if string equal I. We want case insensitive comparison for this. And we're going to say out package internal data types sub j name, and we're going to compare that to the manifest assets sub I. Had a brain fart there for a second. Name. Wait. Type. Okay. So we're going to look up the type, and if we find one, then we're going to do a darray push. Whoops, that's the wrong one. That's the one we want. We're going to push into, you know what? I don't like typing all this stuff out repeatedly. Let's do that. And we'll do asset type lookup pointer equals the address of that. And then we'll do lookup name, right? And even here we can do let's see, this is going to be asset manifest asset pointer equals address of that, right? And then now we can say asset type, right? And then to the array we can say lookup entries, entries, and the value that we want to push there is going to be, let me think about this for a second. We want to dereference asset. And we'll break. Right? And then the next thing I guess we'll need to do is we'll need a flag here type found, found, if I can type, equals false. We'll set that here before we break. And then once we get down here, we say if not type found. Then what we'll do is we'll say, okay, we need to create a new lookup for this. So we'll say asset type lookup, new lookup equals, and we'll just null that out for now. And we'll say new lookup name equals string duplicate, and we're going to take the asset type directly from that, right? And then we'll do new lookup entries equals darray creates, and the type of that is going to be what is it? Asset entry. That's what it was. Right? Did I? Yes, asset entry. Okay, so we're going to create the new darray for that entry, and then we'll go ahead and push it, right? So we'll say darray push, and the array we're going to push that into is the out package internal data types, and we're going to push new lookup. Right? And then, so once we've done that, actually before we do that, before we actually push that, we also want to do another darray push into new lookup. Whoops. New lookup dot entries. And the value that we want to push into that is going to be the same thing, dereferenced asset. Right, so create the type lookup list. Push the asset to it, and then push the list to the types list. Right? So if the type was not found, create a new one to push to. And then here we're just push to existing type list. So that's sort of the difference there, right? So as we're going through these, we search, and yes, these are string lookups, right? But again, this only happens when we're first loading things up. And sure, string lookups aren't all that fast, right? But like we're comparing strings that are literally like that big. So it's not really a huge deal. And we're not going to have a long list of types, right? We're going to have a dozen or maybe 24 types. So I'm not really worried about it. Dope. Dingus-oriented programming excellence. That's hilarious. Observer Herb, how's it going? Hello. Trash Can, thank you for dropping that link. I appreciate it. Yeah, the bot is foobar for some reason, and I don't want to waste stream time fixing it. So I'll have to fix that later. All right. You can also have it in the registry or in a converted file. Oh, that's the UUID. My asset manifest looks similar to yours, but with an added UUID. I have a different binary version and packaged archives, though. Yes. So I think we're going to wind up with something probably similar, is what you're saying. You also use meta files. The redundancy allows me to fix user errors and also fast lookup. We might wind up doing something like that, too. I haven't ruled it out. But for now, versus having like a separate metadata file, I'm thinking we just encode the metadata in here. I don't know if that'll work yet or if that's a bad decision, but we'll find out. And if it is a bad decision, we'll fix it. We have our ads starting soon, by the way. Dingus Dev lurking. I appreciate that. Love the name, by the way. All right. Okay, so we figure that out. By the time we get to the end of this, we should have ads. So got a little over a minute on ads, and then we'll be back. $30 seconds left. All right, ads are done. Okay, so I think that's actually all we need to do in terms of setting this thing up, right? We have the name, the internal data, we set our type lookups up as needed, push those things into there. That should be fine. Let's undo this stuff. In the do lookup name. Oh, you know what? Something I just thought of. We don't want to be pushing the asset directly. That's not what we should be doing. Remember, we have this asset entry that we should be filling out instead. That would have been kind of nasty, because like the struct kind of lines up, but not fully. So what we really should be doing is asset entry, new entry, right? New entry.name equals string duplicate, right? Because we want to take a copy of all these strings, because we don't want to think about the life cycle of this asset manifest. We should be able to basically just pass this thing through, set up our system, and then be able to throw it away. We don't want to have to rely on it after that. So in this case, we'll do asset name, new entry path is equal to string duplicates asset path, right? And then new entry, I don't think there's anything else. Size and offset don't get filled out here, right? Size and offset don't get filled out used with a manifest version of a package. Speaking of which, we should probably have some sort of flag that handles that for us. So we're going to have to create that in a minute. But what I want to do before we do that is we're going to go ahead and, actually, let's just do, let's take this. Oops, actually I want this line too. Let's take this and do this here, right? Because no matter what we do, we're going to be using that new entry. So this needs to be new entry, and then this also needs to be new entry. Okay. That's correct. All right, so the other thing we're going to need is in our K package, we probably need, I suppose we could just use a Boolean for now. Because I think there's only going to be two types, right? We're either going to be a binary or a disk type. So I guess we'll just do B8 is binary. And in this case, what we'll do is once we get past the point of being able to fail, we'll do out package is binary equals false. Right, and then down here, even though we're going to error this, let's go ahead and just, so we don't forget to do it. We shouldn't be doing that, but just this, right? Also, we should probably also be checking. Let's put this in here before we forget it as well. And instead of manifest, bytes, right, so we need to have size, bytes, and out package. Requires valid pointers to bytes, and out package, and size must be non-zero. Okay, and then we're still gonna bleat about this. We're not going to support this right away. We're going to do that on the second pass, right? Okay. So we have that. We do need to handle the destruction of this. So before we destroy our internal data, we need to say if internal data package internal data types, right? So if the types exist, U32 type counts equals darray length, package internal data types U32 or U43, that's fine too, equals 0, I is less than type count plus I, and then so we'll say if, actually let's do asset type lookup, lookup equals address of package internal data types sub I, if lookup name string free lookup name, if lookup entries, then we need to do another loop. So U32 entry count equals darray length lookup entries. Oops, I didn't want that. For U32 j equals 0, j is less than entry counts plus there's that dingus oriented programming again. Okay, and then we'll do what is is this bleating about? There we go. We'll do a asset entry. Why did it? Okay. Asset entry equals address of lookup entries sub j. If entry name, then we do string free entry name. If entry path, string free entry path. Now, some of you might be going, well, you know, if we're freeing this stuff, we should be setting it to 0, but we're literally going to, we're destroying stuff inside of a struct that's going to get destroyed itself and freed itself. So we're not going to bother doing that, right? So we clean up after each entry in the lookup. Once the lookup itself is done cleaning up, right? So once we have all the entries removed, we'll do darray destroy, and then we'll do lookup entries, right? And again, I'm not going to bother setting that to 0 because we still have to actually destroy all the lookups as well. So that's going to be after we've gone through all the types. We're going to do darray destroy package internal data types. And let's see, is there anything else? That's it. That's all that's in there for now. Okay. So we clear out all of the types, all of the entries. Right. Right. And then once we're done with that, we wipe out the internal data, and then we zero that struct out, and we're done. Okay, so that's all we should need to do to stand this up initially. So the next thing we need to do is actually perform this get operation. Let me catch up with comments first, though. Does Kohi already have shader reflection? By reflection, I mean SPUR-V. No, not yet. It's something that I've been experimenting with on like a different branch, although admittedly I haven't touched it in months. But it is something that I want to do, so that maybe we can get rid of those config files. Because right now we have, let's see, we have, for these shaders, we have the 2 GLSL files, right? So one for frag, one for vert, and then we have this shader config file that gives us a bunch of stuff. It gives us also, first off, the name, what stages it has, the files for each of those stages, which those are fully qualified now to look up using our packaging, right? A few parameters like does it depth test, does it depth right, and this is really, does it need to support those things, not does it do it, right? What kind of topology it supports. So this example can either work with lines or triangles. And that just determines what pipelines we stand up under the hood. And then we have our attribute list and all of our types here. We use that to deduce, how many bytes are actually in the UBO and stuff like that. And then our uniforms. And then you have ones that are a little bit more complicated, like, like this one, that have a bunch of attributes, a bunch of uniforms, which also declares scope, right? And then we also have, samplers in here as well with different types. So this sort of metadata is sort of a configuration not only for what files we're going to be loading, but also for the actual graphics pipeline that gets loaded behind this. So this is going to be a little hard to remove with just straight reflection, because reflection will actually tell me for example, that projection is a mat 4, right? But it's not going to know, well, maybe it'll know what descriptor set. Essentially, this becomes descriptor set, right? So 0 is global, 1 is for instance, 2 is for local, which is a push constant. I guess reflection technically would give us that too, actually. So that's going to be the trickiest part to figure out, but at some point, I'd like to support that. The only thing is I have to make sure that reflection is actually possible on both Metal and Direct 3D before I do that. Because if I have any sort of rendering backend that doesn't support that, then I'm screwed. Yeah, but yeah, we built an initial version of this a long time ago, and then we enhanced it to actually allow array types. Direct3D 12 supports reflection just fine. That doesn't surprise me. What really is the wild card is Metal. Never looked up that closely. Maybe Tammin would know better. Yeah, Tammin probably would know. All right. Are you planning on putting each asset's dependencies in the manifest too? It could make building a minimal asset package faster. And you probably need a dependency graph for hot reloading anyways. So that's a good point. And it is something I've loosely thought about. We actually built a dependency graph already in our render graph. So I could probably just reuse some of that logic. Have you considered using one file for all shaders instead of having them in separate files? That way you could reuse functions easily. I hadn't considered that actually, but now I am. One thing that I have thought about doing though, while we're on that topic, is we do have this shader config file, right? Which is this sort of old format. This is what all of our files used to look like for configurable items before we came up with this format. So I do want to convert this to this format, but then also extend this format maybe to allow us to have like almost like C data tags in XML that allows just like freeform data. And maybe we could embed GLSL in there. Can also include the metadata, depth stuff, wireframe, etc. in that one file. Yeah. So it would contain both the shader logic as well as this itself. Yeah, it's a good point. The renderer right now is actually responsible for knowing that. So like when let me bring up the debugger for a second. So if I do, and again, I'm only getting away with this because I haven't actually built this yet. So right now the stuff exists in here. So if I go into shaders, right, and I do I don't know, I guess our water shader, right? Which I actually haven't. Here it is. This is before like all the stuff was renamed, so it takes me a minute to find it. So let me just open this, right? And I'm going to run the engine. And load this up. And I'll go a little closer to the water so you can see it, right? So if I come over here, an easy change, right, is I apply some sort of tint that I'm eventually going to have be configurable, right? But let's change this tint to be like red, for example, right? So if I make this change in the GLSL right now, this actually will hot reload in the engine as we speak. So there are currently file watchers that actually do rebuild the pipeline and stuff and reload this. So we do have some of that stuff in place. We just have to put a file watcher on each one of these things. And then, but one thing that won't work is like, I can't go into the actual shader config file. I can't change this file. Only these get hot reloaded. So, because changing this would require a rebuild of the entire pipeline. Reconfigure and rebuild. versus these, I can just kind of reuse the same pipeline that already exists. All right, now let me undo that before I accidentally check that change in, because I really, really do not want that, right? So yeah, we already kind of do have that, but like the renderer is responsible for it. So yeah, you're right. A dependency graph might be nice for sure. Do you have a hot reload of C code? We do. Although admittedly, it's probably broken at the moment because I haven't messed with it in a while. And I changed a bunch of stuff that might break it. I'm not going to bother revisiting it until we're done with some of the stuff that we're doing, like asset stuff and whatnot. But yeah, we do actually have that. We have oops, wrong one. In here, this is our sort of entry point into our test bed. And we have, gotta remember exactly where it is. Right here, platform watch file. So when this guy kicks off and the file's been written, we do this watch file updated, and we basically unload the dynamic library, sleep for a second, and then load in the new one over top of it. So we do have that at least, but that's up to the application to actually implement. It's not something I'm adding to the engine itself. The engine provides like the platform code to do it, but in terms of having that be core functionality, I don't really see a use for it in the runtime. You like HLSL better than GLSL? I'm just used to GLSL, so that's why I went that way. HLSL is awesome, to be honest, unless you need to use Vulkan specific stuff like BDA. Yeah, fair enough. But yeah, like I said, I'm just more familiar with GLSL because that's most of the stuff I wrote in the past. I did a lot of OpenGL in the past, more so than DirectX. Okay, stepping back from the sidebar. Okay, so we were going to perform this lookup thing, I think. I think that was more or less where we landed. So there's actually some of this that we're going to be able to reuse. This right here. So I'm just going to actually take... I'm going to take this section. All right, so actually, I'm going to turn that into a early boot out if some of this stuff doesn't exist. So if not package or not type or not name or not outsize. K package assets bytes get requires, oops, quotes might help. Valid pointers to package type name and out size. Okay. So search for a list of the given type. So that's what we're going to do first. Instead of out package, this is just package. Okay. So we're going to look through each one of those. Instead of comparing against asset type, we don't have asset. We do have, oops, we do have type though. So within that, we're then going to, actually, I don't think we need this type found thing. Okay, so search the type lookups entries for the matching name. Okay, so again, U32 entry count equals darray length, and that's going to be lookup entries for U32 j equals 0, j is less than entry counts plus plus j. We want asset entry is equal to the address of lookup entries sub j. And then we'll just do, again, string equal I, and we want to do entry name. Right, so if those things equal, then we have found the thing. So the next thing that we need to do is we have to branch based on what type of package we're dealing with. So if package is binary, first off, we don't support that yet. So binary packages not yet supported. So we're going to just abort that, essentially. Otherwise, we will go ahead and load the file content from disk, right? And then we'll return those bytes. If we get all the way down past all this stuff, we don't need that break either there. So either way, if we find a matching thing here, then we're going to return it one way or another, right? Even if that return is a failure. If we actually reach all the way down here, let's actually be a little bit more specific about the error catching scenario here. So if we found the type, but we didn't find a matching entry, then no entry called exists in type or of type, and then we'll do another string, and then we'll output name and then type. Right, in this case, we'll return 0. If we get to the end of this loop, all the way down here, then that means the type itself wasn't found. So kerror package s does not contain a type of, a asset type of. Right? And so we could say package name and type. I suppose package, we'll put the package here as well, right? Just for a little bit of additional context. And we'll put package name, right? So we'll output the package name if we run into any errors. Okay, so the only thing we need to do now is load the file content from disk. The only thing that we're going to do and this is where I'm trying to debate whether I want to actually treat any of these as text, because some of these are text. Like this is a text file, right? So I could theoretically just treat it as text, or I could load the binary. Because opening a file in text format versus binary format actually does make a difference. Oh, we have ads. Ads do make a difference as well. So for those of you who are new to the stream, we do pause the stream whenever ads come up just so that nobody misses any content. Because nothing sucks on a programming stream more than, a full screen ad coming up and you can't see or hear what's going on because there's an ad playing. So out of respect to you guys, we pause the stream. Got about 40 seconds left on ads. There's actually something else we're going to have to consider at some point too. And I do actually want to bring this up as a to-do item. I was thinking about maybe leaving it, but now that I'm thinking about it a little bit more, maybe not. Before I get to that though, discussion about reflection above. Some things you might have to consider. Oh, good. Okay. Let's see. You can solve this issue by using macros probably, because similarly for Direct3D 12, you also have to specify resource bindings in a very specific way. So those resource bindings, I assume they're like they're indexed bindings, right? So if those bindings are indexed in the way that they are for Vulkan, then that still works. I should still be able to set it up in a way where I can say, well, okay. So for Vulkan, you have a concept of descriptor sets and then descriptors within that descriptor set, right? Or descriptor bindings within that, right? So the way that I have it set up is I have two descriptor sets. One is global, one is instance, right? And within those sets, I then have a single binding for the UBO and then bindings for samplers after that. And the same is true for the instance. I have a single binding for the UBO and then sampler bindings after that. So I don't know if Direct3D can do something similar, then we should be good. Ordy Hydro, first time chatter, welcome to the stream, by the way. When you come back, can you explain the difference between opening a file in binary versus text mode? Yes. Most of it revolves around the difference between when you're actually loading up the file, dealing with carriage return line feeds. So on Windows, a new line in a text file consists of actually two characters. There's what's called a carriage return and a line feed. And if you ever see the escape sequence, it's \r/n, right? And so \r is the carriage return, and then n is the \n is the new line character, right? So carriage return, essentially it's kind of a leftover from like the typewriter days, where carriage return would take you back to the beginning of the line, and then line feed would bump you down the line, right? So Windows, for some reason, does carriage return line feed, but all Unix-based operating systems do line feed only, new line only, right? And so when you open a file as text, the standard C library sort of takes that into account and converts all carriage return line feeds into just line feeds. So that in your code, you don't have to worry about the difference between that. If you were to load that in binary, that's not going to actually happen. So things that revolve around or depend on just there being just a line feed, because that's what you normally get when you use the C library to load files, are going to have a problem, because now on Windows, you're going to have this if the file is encoded that way. And so that's just kind of what we have to be careful about. Now, I mean, I could do some processing on that to try and eliminate that, but that gets kind of ugly too. So that's one of the reasons that I'm thinking I may have to treat them separately, but I'm not going to do that. I'm going to try loading it binary and see where I get. But so binary means actually seeing what was in the file. So yeah, it's literally loading up the bits that are in the file, the bytes that are in the file. So you're literally like taking the file and just loading it directly into memory as is. You're not doing any sort of parsing on it. Yeah, for the Direct 3D12, you have registers and spaces. Okay. So, I guess which one's which? Because I'm trying to think of which. Is a register exist inside of a space? That seems like the way that should be. Again, I haven't looked at Direct 3D12 at all, so that's going to be interesting when we go to implement that here, because I'm going to be learning it as I'm implementing it, which should be interesting. All right. We could include metadata that says process this type as text. Right? So like, obviously if the type is text, we'll open that as text. That's easy. But like for something like the material, that's a text file, right? But it's a material. So I don't want to have to like include a lot of that in here, a lot of those checks for hard-coded types. Thank you for the follow. Appreciate that. So I guess how do we want to include because what I'm trying to also consider is there's going to be user types of assets. And there's going to be plugin types of assets that aren't actually existing in the engine core. So for example, let's say that a plugin adds scripting support for a particular language, right? Like Lua or C# or something like that. Somebody writes a plugin for that. This code isn't going to know about what those types are or how to process that file, right? And you might say, well, just treat that as text. Maybe that's what we do. But if the user wants to add sort of their own type of asset that is text, but they don't want to classify it as text, that could be a problem. Like maybe a CSV file or an XML file, right? Like maybe that goes to a different handler or something like that. Do we include, maybe we have another section in here for specific type info, but then that could technically, you could technically have conflicting data in different packages if we do it at the package level, right? It's really got to be like almost like an engine configuration level thing. Right, so like maybe in our app config, right? So we have all this stuff in our app config. maybe we do it in here somewhere. So maybe we have something like let's see. Let's do maybe like package config, right? And then process as text, right? And then inside of each one of these, there'd be like material, right? Or CSV, right? For example. And maybe this just gets read in as part of app config. And then this allows the user to enter their own types that they want processed as text versus binary. Let's see. Maybe implement a hash map. We do have one, actually. We're just not using it because this is sort of the brute force method just to prove that the process works. And then we'll get fancy with hash maps, right? So my process behind this is just get the bare minimum working, and then come back and enhance it once it's up and running, right? We can always enhance it with hash maps and stuff like that to be able to look it up. So I guess we could do something like this. Although we probably shouldn't require this either, because there are certain core types that the engine needs to process as text. So we may have like an internal list that contains like material, right? But then the user could put CSV. So maybe we do maintain a list internally of types that are treated as text. But then we also allow the user to add more. Right, because we don't want the user to be able to shut this off. So it would really wind up being, just that, right? Or some user asset type. Let's see. Yeah, you can repeat registers as long as they are in different spaces. Like register T0 for textures can be assigned 2 textures as long as they are in different spaces. Just recently discovered that the info queue callback function only works in Windows 11. Oh. So they still haven't gotten away from tying direct 3D versions to operating systems. That's so stupid. Texture 2D, text 1, register T0. Oh, I remember some of this stuff vaguely. Usually on Arch, but I have a Win 10 dual boot and it didn't work. Okay. Had to use the old-fashioned IDXG info queue. Oof. Okay. Well, it's good to know that Microsoft can't maintain compatibility within their own ecosystem. That's good. It's an interface for getting errors from Direct3D 12. Okay, fair enough. All right, so I guess let's have an internal static list, I guess. And then we'll be able to provide some way to sort of add to that, right? So let's do a lookup, and we'll say text asset types, I guess. And so we can say material. Let me think. What are some of the other ones? These GLSL files were actually already considering text files. Let's look in here. Actually, let's look in here. So KSN, so scene files are also in that list. Shaders, sounds, terrains. Terrains are in that list. Textures are not. Okay, so that might actually be it. It's just those ones for now. We'll be adding more that have to exist in there as well. Is it really not going to let me do that? Probably not won't let me do that either. Nope. Well, I guess it would be that is what I want, I guess, for now. So types of assets to be treated as text. And again, we're going to want a quicker way to look this up, right? This is just sort of a brute force scenario to think about. So I guess let's just do a quick B8 type treat type as text. Type. Right, and then for, actually, let me do define text asset type count 3. Right, and then I can come down here and I can use that. For U32 I equals 0, I is less than text asset type count plus I if string equal I. And again, we'll probably have like a hash table to look this stuff up. I'm just doing this stupid brute force way now. Type, and then we'll have, what did I call that? Text asset types. Text asset types, sub I. Right, so if those strings are equal, then that means it is supported. So return true, otherwise return false. And that way here, if treat type is text, and then we can say type, load as text, else load as binary, right? Now we have a surefire way to look that up. And then we'll also support this at some point where users can add their own types to this list. All right. So the next thing we're actually going to need is include platform file system. And this is the bit that we might wind up having to redo a little bit of. So the file system has a couple of convenience methods. So we're going to do read all text, right? And so that basically takes a file handle and outputs everything into a text array and tells us how many bytes out we read, right? And then we also have one for read all bytes. So this automatically handles for us reading it as text or reading it as binary. So I guess we can do, let's do file handle file system open, and we'll do path, right? So that's going to be, let's see, where do we have, it should be entry path. And so the file mode here, oh, we actually do need, it actually matters how we open this too, as well as what function we use. Okay, not a big deal. We're just going to move this here. Is text equals that, and then say is text, right? And then we'll do is text file mode. Oh wait, this is just read or write. Binary is what we need. Okay, so file mode read. Binary is not is text. And then the out handle is going to be the address of f. Okay? And then, of course, we need to check that, right? Because I believe that returns a Boolean on success. Yes. So we need to say if, for some reason, that fails, failed to open file at path. And let's actually be a little bit more explicit about this. So we'll say package name failed to open asset name file at path, right? So we'll say package name, and then we have asset name, and then we have entry path, right? And then we return null in this case, right? Okay, so we have our file system open, and then we have our file handle that we can use down here. So we can do the address of f, and then we'll need a buffer to hold our text, and then the amount of bytes read is actually just going to be outsize. Spiro with a raid. How's it going, buddy? Thank you so much for the raid. What were you getting up to on the stream? I saw that you were streaming, but unfortunately I wasn't able to hop in. What'd you get up to on stream tonight? Quick shout out to Spiro, by the way. He is a GigaChad developer here on Twitch. He's also a good friend of mine. He is always doing really cool things with Zig and Wasm, actually, on his channel. He actually has quite a few different things that he does, but one of them is a really cool game that he's building that's actually interactive with Twitch chat, which is really cool. And so I highly encourage you guys to go give him a follow if you aren't already. Working on the WASM grid assembly. Assembly thing. Yep. Okay, fair enough. Managing UI via grids via WebAssembly. Yeah, see, so that's an example of like the awesome stuff that he's doing. So yeah, definitely give him a follow if you're not already. Okay. So for the Raiders, for any of you that might not know what we're doing here, we're building a game engine from scratch using C and Vulkan as our initial rendering backend. I say initial rendering backend because we are planning support for Direct3D 12 as well as Metal as additional rendering backends. So the series, basically, the long and short of it was the series started off as a educational like YouTube tutorial series, and we changed formats, tried a few different things, ultimately landed on the live stream format that you see here. We've been at it for a while. I do have, actually, I can still actually run this because I haven't tried to compile yet. So we recently added water, but we do have the ability to load static meshes, terrains. We do have cascade shadow mapping. We do have PBR for our lighting system. Oops. And so we recently added water, which I think is looking pretty slick. And that was really a nice visual update there. We have different like debug views for it, so you can look at a lighting only view if you want to, or normals only, or the cascading shadow map view where you can see what cascade you're currently in. It's makes a little bit more sense out here, right? And there's also a wireframe view available. And so yeah, we've been adding all kinds of stuff, and now we're actually adding an asset packaging system. So the asset packaging system is more or less what is going to solve our asset issue and allow us to distribute assets with different modules. So we'll be able to have assets that are distributed along with our UI system, which is a plugin and which is optional. So if you're using it, not only do you get the code with it, but you also get the assets with it. And the same goes for, the runtime really isn't optional, right? But the runtime also supplies some assets of its own. And those would all be kept separately from, of course, the application's assets. And so we are creating a packaging system now to be able to look up items by asset name. So an example of this would actually be, let's see. I guess a good example would be in our fonts, not this one. In here we have assets, fonts. So basically all asset lookups would be the name of the package, then a dot, and then the type of the asset, and then a dot, and then the name of the asset, right? And so as far as the package is concerned, it only really cares about this, right? And then there's an internal lookup list for each type of asset that's within the package that holds, a collection of these, and then, this is the package itself, and these will be managed by the file system. And that's kind of the way that we're gonna do that, because then none of our code has to worry about paths on disk. It only has to worry about an asset name, and that's it. Doesn't care where it comes from. And so our packaging system will have two ways that it works. One way will be sort of a binary package where everything gets rolled and baked into one huge package that gets shipped. Or for debug builds, you have an asset manifest that looks like this, where each of the assets essentially point to a file on disk. And the advantage to that is these could then be set up for hot reloading for debug purposes, but that could then be disabled for release builds. We are also going to have ads popping up here soon, and I do pause the stream whenever ads come up so that you guys don't miss anything. So that is going to be popping up here. It'll last for 90 seconds, and then we'll be back. Trinket Links, first time chat, welcome. Appreciate having you here. So yeah, we out of respect to the viewers, we pause the stream whenever ads come up so that nobody misses anything. And so that'll be here probably in the next, I don't know, around 30 seconds, maybe a little less. But yeah, that's what we're working on tonight. We're working on sort of the pointers to file on disk tonight, and that's what we're solving. There's the ads. So I hope all of that makes sense. Thank you so much for the follow. Appreciate that. And you can see our ad screen actually has the newly rendered water on it. I might make that a video at some point. Record like a 90-second video to run while ads are running. Just to make it a little more dynamic and nice looking. Thank you guys for the follows. I appreciate that. And yeah, if you guys ever doubted, Spiro is also a mod here too. So that's how well we get along. We're on the same wavelength about a lot of things. Mwahaha, yeah. He's been itching to use the ban hammer. Don't give him a reason. He put it on the YouTube side too. Nice. All right. I think ads are done. Hold up, $50 a month for gaming internet. Now, what kind of whack scam is that? I pay $140 a month. $140 a month. Jeez. I have fiber here, and it's $79 a month, I think. 75 a month, 79, something like that. Oh, Cox. I've never had them, but I've heard that they're kind of a terrible provider. I used to have Spectrum, and they were fine. They were reliable, but like the speed I was paying for that was like less than half of what I get on fiber for the same price. Our electric company here actually offers fiber, so when I found that out, I'm just like, oh, I'm dumping onto that for sure. Okay. So the only thing that we need to do here is create a buffer, right? So when we read all of this text, like we have the out size, right? But we don't actually have like a buffer to put in here yet. Like we don't have enough sort of information. Like how big does this buffer need to be, right? And so I don't think this isn't one of those call twice kind of deals. So what we're going to have to do here is we're going to have to query the file. And we can do this right after we open the file, actually. So we can do file system. Let's see. File system size. It's the one that's right there. So we'll pass the address of F, which is our file handle, and then out size. You know what? We'll actually just put into out size. Fair enough, right? Thank you for the follow, Trinket Links. I appreciate that. Wanted to learn coding, but it's a bit over my head. I can software mod OG Wii to play Game Boy Advance, SNES, Genesis, PS1, RPG Maker 2003, and even a single PC game, though. I mean, it's a learned skill just like anything else, right? Like, I started programming when I didn't know how to program. Everybody that programs starts at that point, right? It's never too late to start it. I've had folks in chat here that have told me that they've started in their 50s and 60s, started programming, and they love it, right? And they've gotten really good pretty fast, actually. So yeah, duck in and start learning, Problem is everybody suggests differing languages and differing engines and languages. Had tried C#, Unity 3D. Okay, so here's my advice on that, and take this for what you will, right? But I'm going to give you a little bit more open-ended advice, and here's why. Think about what you want to make. Think about the type of game you want to make. Do you want to make a 2D game? Do you want to make a 3D game? Right? That right there will help you decide what engine you want to use. Because 2D doesn't require all the stuff that Unity does, for example, right? There's lots of other engines out there besides Unity that does 2D stuff. So if you want to make a 2D game, like you could use Game Maker for okay, open world 3D. Okay, so that does limit your options somewhat, right? You have Unity, you have your Unreal, you have Godot, right? I would say do a little research into each one of them and figure out which one kind of fits the need that you're kind of going for, right? I know Unreal's networking code is pretty good, but their renderer is super heavy, right? So Unreal is usually one of those engines you use if you want like ultra, like super realistic stuff, right? Whereas Unity, if you don't really, care as much about being super ultra realistic and whatnot, Unity, I used to suggest as a decent option. However, with all of their all the crap that they pulled several months ago, I don't suggest Unity at all ever anymore. Just because of all the toxic kind of things that they put out there in terms of licensing, and all the stunts they pulled. Even though they backpedaled on it, I don't trust them never to pull it again. So I don't suggest Unity ever. I would say if you're not going to go Unreal, go Godot. It's a free and open source engine. So, you have to actually spring clean your desktop. You only have 100 gigabytes free. Yeah, and Unreal will take a decent amount of that. What did Unity do? Well, I won't go into too much details here, but they basically said that they were going to start charging developers per install of a game. It was like 20 cents per install or something like that, which would absolutely bankrupt like small studios, right? Because all you would have is just some troll out there that would just, sit there and like set up a bot to just install the thing over and over and over again and ramp up that count, right? And it's other licensing stuff that they've done. I would say Google it because it was probably 6+ months ago, so I don't remember all the details at this point. But it was bad enough that made me never want to touch it again. Because, it's like they already threatened to pull this stunt once, and yes, they backpedaled, but what's to keep them from actually doing it, I would try Epic's gameplay ability system asset if you make any kind of RPG plus network with Unreal. There you go. There's some solid advice. Unreal's a solid engine. I have used that before. I've not personally used Godot, but I've used older versions of Unreal. I can't speak for Unreal 5. I haven't used it. I did use Unreal 4 a little bit. Most of what I did was back in the Unreal 2 and 3 days. It was a pretty solid engine back then. These days, it's pretty heavy. All right. So yeah, I hope that helps. But yeah, definitely read up on Unity a little bit. Look up, some of the controversies that surround that engine. It's not good. All right. So we also need to check failure on this. Fail to get. You know what? Let me just copy this. Fail to get asset, get size for asset, file at path. Okay. All right, so we open the asset, we get the size, and then we can use that to create a buffer, right? So we'll do a... We'll create this conditionally based off of the is text or not. So I guess it doesn't really matter. we're going to create a void pointer, right? And we're going to say file content, right? And we're going to say equals kallocate, and the size, we're going to use the dereferenced out size. The memory tag is going to be memory tag resource. That's what we're going to want to use there, right? And file content is what we are going to pass, here, right? And we also need to check this to see if it was actually successful. Right, so we'll again copy this, modify it a bit. Failed to read asset blank as text at file path, blah, blah, blah. Okay? So that's the load as text, right? If that's successful, we've loaded everything into that buffer, we're going to return. Actually, you could just do it down here. Return file content, right? Now, load is binary, almost the same thing. Brunzino, wait, no, I completely butchered that. Dyslexia, hello. Bruinzo, thank you for the follow. Appreciate that. So we're going to change this from read all text to read all bytes. Right, and I believe the parameters are the same. Yep. Okay. And we're going to do read as binary. Perfect. Okay, so if we error in either one of those scenarios, we're just going to return null after bleating about it. Otherwise, we return the file content. If we do not return the file content here, this is the only success return, is right here, right? So everything else is a failure, all the way down. Okay, oh, this is returned false. This should be return 0. Oops. Which is technically also 0. That would have worked, but okay. So there's our lookup. And again, we're going to do a pass on this to use hash tables and stuff like that instead of looping through and doing string comparisons, right? But for now, we're doing this brute force just to get something working, right? And we know that this is going to work. So this is basically more or less our interface for pulling a file off disk by using a fully qualified name as we've defined it. So that one we can check that off. The next thing that we're going to need to do is this is from the perspective of the individual package itself. So we need one step above that where we have something that manages all the packages that are loaded and can say, okay, for this package name, go here, for this package name, go here, for this package name, go here. And then something that can also keep track of these package references that we have, right, which we haven't really dealt with yet. And I believe we might actually, I was thinking about calling it file system, but I think we're actually going to call it virtual file system to differentiate it from file system. So we're going to set up a virtual file system that sits on top of this package interface that allows us to pull things by fully qualified name. And by fully qualified name, I mean, if we look in this font file, for example, we have this right here. So we have plugin standard UI is the name of the package, texture is the type of asset, and then Noto Sans 21 pixel _ 0 is the actual name of the asset. So that is what we mean when we say fully qualified asset. Let's see. Yeah, they walk back some of their pay per install stuff, but I definitely don't trust. Yep, exactly. After they even, because here's the thing, Unity came out and publicly said that they were going to do this, right? If they were willing to go that far with it, what else are they willing to do, right? Even though they kind of walked back some of it, not all of it, you know, that's sus, to say the least. Let's see. Have a big issue when it comes to design, though. I'm far too ambitious. Noto actually has a good point here. Try some game jams. They force you to learn how to think smaller due to a short time. I learned that because I made lots of very small games that had to release quickly. So one of the game studios that I used to work for, we released an average of a game a month. So yeah, that will really force you to think small for sure. Clearing space so I can install Godot, isn't it like 50 megabytes? I don't know what the size on Godot is these days, actually. It's certainly not hundreds of gigabytes like Unreal. Yes, but I need space to make a game. Yeah. Hard drive space is kind of important. Godot's nice. It's a good engine. Yeah, it is. It's come a long way. A game a month? Dang. Yep. Yeah, and that includes design time. And testing time. So, yeah, you're realistically talking max 2 weeks for development. All right. So I think we've actually made pretty decent progress tonight. This is actually, I'm pretty happy with this. So let's take a look at our to-do, because I want to update this a little bit. So we actually have created this interface. So we've got that done. One thing we didn't mention in here, and I guess this isn't part of asset packaging. This is kind of above asset packaging. Virtual file system. Right, we're going to call this VFS. VFS. Sits on top of and manages packages. Let's see. Doles out requests to loaded packages, etc. Okay, so the virtual file system will sit on top of that. I don't need to go into too much detail there. I think that's going to be relatively thin. Most of the file system abstraction is actually going to happen through the packaging layer. Which is going to make this really thin, actually, but I'm okay with that. Let's see. So what do we have left? We need to rework some of our imports. We know that. This I'm probably going to wait on until like towards the very end. In fact, I'm actually going to move. I'm going to move that down. Whoops. This. There we go. Point K package files on disk for debug builds. We kind of have this half done, but we don't have the ability to turn that on and off yet. I mean, we can turn it on and off through a Boolean, right? But we don't have the thing that actually sets the Boolean, so I'm not gonna check that off yet. We don't actually have any of the rest of these things done yet. So this is basically like our to-do, our work item list for the next several streams. Oh, I fixed this. That was previously fixed. Yeah, we have some things on the platform layer to catch up with and stuff like that. Okay. And then we have some items in here for performance pass too, but we're not going to touch that for a bit. All right. I'm pretty satisfied with this. Let's go ahead and get this checked in. So there's the stuff that we changed. Let me just do a diff on this real fast. Okay, we added that to the package config. Okay, that's fine. Oh, you know what? There is one more thing we can hit. In our app config, our package config, right? We need a package list, right? So runtime. Plugin standard UI and testbed, right? So that's how we're going to know what packages to load. So we're going to need to hook that up and parse that out of our app config as well. All right. Godot also supports C# if you want to learn C#. C# is harder to learn, but would be a good skill. Yeah, I mean, the problem with Godot script is it's specific to that, right? It doesn't transfer, but yeah, I don't know how good their C# support is. Whether that's good or bad, I don't know. All right, so work in progress. K package. We're going to say scaffolded K package interface and on disk file pointers loading. Right, so this will be up on the feature branch called K package if you guys are interested in that code. We haven't tried to build this yet because I know it's not going to build. So there's no point in really trying, right? Okay, so with all that said, this is where we're going to end the stream because it's about ending time. So I think this is a good point to stop. I don't want to like start on the next step and then like get like part of the way into it. So I think this is, you know, we ran a little long last night, so I think we'll make up for that and just kind of end a little bit, like 5 minutes early tonight. So I do want to say just real quick, we're going to pick somebody to raid here in just a second, but I do want to say real quick that I appreciate all of you guys being here on both sides, the Twitch side and the YouTube side. Thank you guys very much for being here. If you haven't already, I would really appreciate a follow on one side or the other or both would be obviously ideal. I'm trying to grow both channels. The more people I can reach, the better. So I really appreciate the support and the word of mouth, you know, spread the word, right? We're building what I think is pretty cool stuff here. So I really appreciate you guys being here. Okay. So let me see who is on and available to be rated. Ideally, I'm looking for somebody that I haven't rated before, because there's some channels that I've rated a lot. But I also want something that's kind of related, you know? Let's see. Okay. There's... This one kind of makes me laugh. So this person's title is this. This dumbass streamer has no idea what he's doing. That kind of makes me want to rate him. That kind of cracks me up a little bit. So yeah, I think we're gonna raid him and see what's going on there. Let me just make sure that they're actually at their desk. Yeah, it looks like they are. Okay. Let's see. I don't know what they're coding, but let's go ahead and check that out. All right, so we'll kick that right off. Thank you guys very much for joining and being here and rating and all that. I really appreciate you guys. And yeah, we will catch you on the flip side. All right. See you guys.